Hi everybody. Thank you so much for joining us tonight. We have a great attendance here in the audience at Jackson Systems and as well online. I'd like to take a moment to introduce you to our trainer tonight, Elijah. Come on in here. Elijah's going to be talking to everyone about zoning 101. He's an expert in this field. He's one of our engineers that works here at Jackson Systems, and he's going to give you a lot of great information tonight. Anyone online that has absolutely any questions that they would like to ask, please type them in. I will ask Elijah for you. Anyone here in the audience that has any questions, feel free to speak up and enjoy the training. Elijah, take off.
Thank you, Jillian. Welcome, everybody. Everybody who came here tonight. We got a lot of people online, I understand, so everybody who's watching online, welcome. As she said, anybody, if you have any questions as they come up, feel free to type them in that chat box. And Jillian will let me know what your questions are. There is a little bit of delay, I understand, on those. So if it doesn't pop up immediately, don't be too worried. And that goes for anybody here as well. If you have any questions, just raise your hand. I'll be happy to talk about anything. We got plenty of time. So I'm going to be talking about zoning 101. So this is our zoning basics class. So this is just going to be the fundamentals of zoning, why we do it, how we do it, how to talk to your customers about it. And just some of the fundamentals you need to know to go into zoning. This is not a more technical training. We are having a more technical zoning training coming up next month in May, so you want to come back for that. But this is your more basic overview. So without any further ado, let's get going here. So first of all, we have to acknowledge the problem with thermostats. Problem with thermostats, any thermostat, well, almost every thermostat, there are some that are starting to address this now, but any given thermostat can only sense temperature in one location at a time. Even if you have remote sensors and you're doing averaging and whatnot, you're only measuring from a fixed location. And so that's the only spot where you can really be sure you're going to be comfortable. If you've done your load calculations and your duct design, your equipment sizing correctly, you should be pretty comfortable in most of the house. But again, because you're controlling from that one single point where the thermostat is or wherever the thermostat's sensing from, that's the only location where you can be sure you're going to be comfortable in the house. And with HVAC, it's all about comfort. So you're frequently going to see stuff like you see on the screen now where you got a two-story house and it'll be nice and comfortable downstairs in the hallway where the thermostat probably is, and upstairs it'll be a few degrees warmer, and on one side of the house it may be warmer where the sun's shining and all that, and that's just natural, the natural sources of different loads. So you're not going to be very comfortable or not going to be equally comfortable in all the locations of the house. Depending on the house, you could be very uncomfortable in some locations. A lot of two-story houses like this, it'll get real hot upstairs real quick. So we can address that with zoning. So the main thing we're dealing with zoning is the variability in heat load. So in a house, throughout a house, you've got all kinds of things that are causing differences in the heat coming into the house or the heat affecting the temperature of the house, right? You've got all kinds of variables. And I want to go over just a couple of those. So the first one is the sun, obviously. So this is this is a single-story ranch home, let's say, and let's say this is north here. And so the sun, as we know, is the major source of your heat load from outside, right? But the sun doesn't stay in one place throughout the day. The sun's going to move throughout the day, right? So if this is north here, the sun's going to rise. Let's use a different color for the sun. Sun's going to rise over here in the east, and most of the solar load's going to be on the east side of the house, right? And then throughout the day, it's going to move kind of toward through the southern sky. So most of the sun's going to be on the southern side of the house. No sun on the north side of the house. And in the evening, you're going to have the sun all the way over here on the west side of the house. So your solar load, which is your main source of heat coming into the house, is going to be moving throughout the day. It's not static, right? So that means it's going to get warmer in different parts of the building throughout the day. So that's one major point of variability in heat load. Additionally, you have the human activities inside the house. So some examples of some human activities might be, let's say this is a kitchen here. So you've got a stove, you cook in there. That's going to be a source of human activity. That's going to output a lot of heat. You've got appliances, you got a refrigerator there. That's going to be outputting a lot of heat. If you're cooking, you're going to be creating more heat in the kitchen than when you're not cooking, right? So if your kitchen's on the west side of the house in the evening while you're cooking dinner, not only do you have all the heat load coming from the appliances and the cooking activities and everything over here, but in the evening on the west side of the house, you also got that solar load over there. So all your heat load's over on this side of the house in the evening, whereas in the morning, it's over on this side of the house. You might also have, if you've got workout equipment, let's say over here in the bedroom, you've got a little exercise bicycle or something like that, right? So if you go in there and you exercise, that's going to output a lot of heat. When you burn calories, calories is just a measurement of heat. So when you're burning calories, you're outputting heat. You're generating heat and releasing it into that room around you. So human activities are a huge source of heat load. So these are all things that change throughout the house, change throughout the day. They're not static, they're not constant. And with zoning, we can address some of this. Oh, and in this example here, a lot of times, where are you probably going to find the thermostat in the house at? Pretty good chance it's going to be right here in the middle of the house somewhere in the hallway. So remember I mentioned that the thermostat, or where the thermostat's sensing from, is the only place you can really be sure is going to be comfortable in the house. Well, if we put our thermostat in the hallway like that, yeah, it's in the middle of the house away from windows and whatnot. But if that's the only place we can be sure that's comfortable, I don't know a whole lot of people that spend a whole lot of time hanging out in their hallway, right? So your dog might be comfortable. Your dog's going to curl up right under the thermostat because he's going to be cozy. But all the rooms in your house surrounding it, getting all that variation in heat load may not be comfortable at all. So with zoning, where'd my remote control go? There it is. With zoning, we can start to address some of this stuff. So the primary thing we're doing with zoning is a method of control that allows us to compensate for variation in load throughout a house and throughout the day, okay? So upstairs, it's going to run a lot hotter than downstairs, all right? That's a difference in load between one part of the house and the other. In a single story like this, you're going to see a difference throughout the day as the sun moves through the sky and as human activity shifts through the house, right? In the evening, you're in the bedrooms, or at night, you're in the bedroom sleeping. In the evening, you're cooking in the kitchen or watching TV in the living room or whatever. So the human activity is going to shift throughout the day, right? It's not static. It's constantly changing. So the idea with zoning is compensating for that variation in heat load, all right? We're not trying necessarily to maintain different temperatures in the house or different parts of the house. If you're a kind of person, for whatever reason, you want it to be 74 degrees downstairs and 68 degrees upstairs, that's probably not going to work very well for you. Even a well thought out and well installed zoning system is going to struggle to do that. But can we maintain 72 and 72 in several different parts of the house? Yes, we can, absolutely. So, when we start talking about zoning, you're going to want to talk to the customer about zoning, and you're going to want to stick to your typical sales tactics, typical sales questions. You're going to stick to the open-ended questions, right? You don't want to ask them, are there any rooms in your house that are too warm or too cold? Because chances are, and you already know this, every single person has probably at least one room in their house that drives them absolutely nuts. There's probably one room at least in there that they just don't like being in. It's never comfortable. It's always too cold, always too warm, something like that. So you just ask them, which room in your house isn't comfortable? Where aren't you comfortable in your house? Because there's almost guaranteed they're always going to name something immediately. They know what room they're not happy with in their house. So ask them, which rooms in your house are too cold? Which rooms are too warm? Do you have any areas with unusual loads? So sunrooms, basements, all have drastically different loads than maybe the rest of the house. So these are all things we can help with zoning. And that's all about starting the conversation with your customer, right? Let them tell you what's wrong with the house, and you can address that. Most people probably don't realize how accessible zoning is. Most homeowners, and a lot of times may think that zoning is a super premium high-end residential type of thing, and may not realize that it's much more accessible and perhaps more affordable than they think it is. So give them the option. Let them know that they can be comfortable in more of the rooms in their house, and take it from there. So that having been said, there's a lot of things to think about when we're doing zoning or when we're planning a zoning project. So some of the things to talk about here, and you see the list on the screen. There's duct sizes and accessibility, and this diagram here shows you the different components of the system. You're going to have thermostats, you're going to have dampers. So the thermostats are going to be sensing the temperature. So you're going to have a thermostat in each area. The dampers are going to be controlling your airflow. So they're going to be permitting airflow to the areas that are calling and inhibiting airflow to the areas that are not calling. You're going to have a zone control panel, and that's going to control the whole thing. That's the brains of the operation. It's kind of the traffic cop of the whole system. It's going to be monitoring the calls coming from the thermostats. It's going to control the equipment, decide when to send a call for heat or cool or fan to the equipment, and also decide when to open the dampers and which dampers to open, as well as monitoring various things. A lot of the zone panels, I/O panels, Honeywell panels, will have various sensors. So we'll typically have discharge air sensors a lot of times to monitor discharge temperature, and there's always going to be a method of pressure control. I'll talk about that briefly here in a minute too. So the first thing is duct sizes and accessibility, and how's the existing ductwork laid out. So you want to know, you want to look and see how the ductwork's laid out, because that's going to determine how many dampers you're going to need, what sizes you're going to need, all this stuff. So as an example, we'll go through and we'll do a quick zoning setup on this house that we just talked about. So let's say I want to break this house up into 3 zones. Okay, so I want to deal with the shift in load from east to west, whether it's from solar load or from human activity. So I'm going to break this house up into 3 zones, east to west. And let's say I'm going to break it up right here. I'm going to call this Zone 1. And that's going to have the kitchen and let's say a dining room and a living room. Zone 2 I'm going to have right here. And that's going to be just these 2 bedrooms. And then Zone 3 is going to be these other bedrooms here. So that's how I'm going to break this system up. All right, let's make those a little bolder for you so you can see that. So first thing I'm going to want to have a thermostat in each zone. So we'll put a thermostat, let's say we put one here. Let's see, Zone 2's already got one in the hallway, and Zone 3 will put one in the bedroom here. So we'll need to put thermostats in, and then we'll need to have a good idea of how our ductwork's laid out in order to know how we're going to be able to zone this. Depending on how the ductwork's laid out, zoning can be very simple or it can be very complicated. You're typically going to want to try to have as few dampers as you need, but you're always going to have at least 1 damper per zone. But you have to know how the air's flowing around the house in order to do that. If you've got ductwork that's concealed, if it's behind bulkheads and you can't access it, zoning could be very difficult in that case. But let's go through, and in this case, let's say our equipment is here in this utility closet here by the kitchen, and let's say our ductwork runs this way, And we've got some kitchen registers here. And let's say this ductwork runs this way. And we got some branches going off to these bedrooms here. All right, so let's say I got a ductwork like that, kind of running lengthwise down the house. So if I want to use as few dampers as possible, I need to be able to shut off air flowing to a zone without affecting the air flowing to any other zone. All right, so some of them are going to be pretty simple and straightforward. So zone 1 is pretty simple. I got this small trunk line going this way with those branches, so I can put a damper right there. And I can shut off that zone, all the air flowing to that zone without affecting the other two zones, and that's great. Zone 3 is going to be pretty simple because it's at the end of this trunk line here, so I can put a damper right there, and I can shut off the air flowing to zone 3 and not affect the other zones. But zone 2 is going to be a little bit trickier. Actually, I didn't do zone 1 right. I'll come back to that. So I still need to be able to get, so this line right here is part of zone 1. So I'm going to have to tie that in with that damper. So I'm going to need an additional damper for zone 1. And then those are just going to have to get tied together. And then for zone 2, I need to be able to shut the air off going to those zones without affecting the other zones. All right. And because of that, I can't put that in the trunk line here because if I close that off, I'm going to close off air going to zone 3. So in this case, I'm going to use 2 dampers for zone 2. And I'm going to control the air that way. And those are going to get tied together. And my zone control panel is going to be here in the furnace. So my dampers are going to get tied back there. And my one damper goes here like that. So in this case, I've got 2 dampers for zone 1, 2 dampers for zone 2, and 1 damper for zone 3. So it's a 3-zone system, 5 dampers. All right. So depending on how your ductwork's laid out and how you choose to set up your zones is going to determine how many dampers you're going to need and what sizes they're going to be. So this is all stuff you got to kind of be able to scope out because if you don't plan for that, it could get kind of messy after the fact. So 5 dampers for 3 zones. And you'll have 3 thermostats on there as well. So other planning considerations you'll need to know. What type of equipment, number of zones obviously. So type of equipment and number of zones is going to determine what kind of zone panel you're going to get. Most zone panels are not universal zone panels. So if you have a heat pump system, you're probably going to need to get a panel that makes sure it's compatible with heat pump systems. If you have a multi-stage system, you'll need to make sure you have a zone panel compatible with multi-stage systems. You have a question?
Okay. Ferris asked if he will need a C-wire if you use Wi-Fi thermostat for the zoning area.
C-wire with Wi-Fi thermostats with the zoning area. For most zone panels, you probably will. And I'll talk about thermostats here in a minute a little bit more, but yes, you can use Wi-Fi thermostats with most zone panels. And in most cases, yes, you will need a C-wire, a common wire. Where are we at? Talking about type of equipment and number of zones. So you'll need to have a zone panel that can control the type of equipment you're going to be controlling and that can do the number of zones you're going to control. So if you're going to control 3 zones, you're going to need a 3-zone panel, not a 2-zone panel. So this next question here is the ductwork and equipment properly sized? This is kind of a big one. So we recommend never ever assuming that the ductwork is correct and the equipment is sized properly when you go in to do a zoning job. It can be crucial. Probably more often than not, the ductwork is probably not sized properly. Even if it was sized properly and the equipment was sized properly once upon a time, that's not to say nothing's changed in the house since that equipment was sized. If they do a remodel, finish a basement and whatnot, suddenly you're conditioning a lot more space than it was originally designed to, and no one ever upgraded the equipment, right? If that equipment ever got replaced, a lot of times somebody's going to go out and say, oh, you got a 4-ton system, I'll replace it with another 4-ton system, and never bothered to check whether it was sized right to begin with or whether anything's changed since then. And I say this because if you go into a house that has improperly sized equipment or improperly sized ductwork and you install a zoning system, even though you didn't install that ductwork and you didn't install that equipment, you just install the zone control system, and if something goes wrong now, it's all your fault as far as the homeowner, and in the homeowner's mind a lot of times, right? So you got to be careful. And it's an opportunity for you to set yourself apart from a lot of other people. If you check the ductwork and the equipment and make sure you do the job right, that's an opportunity to do a better job than a lot of other guys are going to do. So ductwork sizing and equipment sizing is crucial. And then lastly, how are we going to manage pressure? So on a zoning system, obviously the ductwork is designed to condition the entire house. Once we start putting dampers in, we start closing off portions of the duct system, we could get a pretty dramatic increase in static pressure. You have to deal with that pressure, at least know what the pressure is going to be to know how to address it. There's a number of different ways to deal with static pressure increase. Yes, sir?
Variable speed blower motors,
Uh-huh.
they affect this too, correct?
Yes, they can.
How do we adjust for that?
Well, so you're going to, when you start closing off zones, the question was about variable speed blower motors. Did you have a related question also? Okay. The question was about variable speed blower motors as to whether that will affect the system, and yes, that it will, pressure-wise. So as we start closing off zones, you're going to get an increase in static pressure. Variable speed blowers, depending on how they're controlled, if they respond to static pressure, then yes, they would respond to closing off dampers. So a lot of times, in a lot of cases, some variable speed blowers will be fine on their own without any additional pressure controls. If you put in some further pressure control, you have to be very careful sometimes. If you put in a bypass or something like that and you have a variable speed blower, you want to be very careful because then you have basically two different systems that are going to be responding to pressure potentially differently. You don't want to end up with a situation where you're going to have those systems fighting each other.
Because I've run into a high limit switch situation where
Right.
it's popping all the time and had been for several years and nobody caught it.
Yeah. And one other aspect. I mean, anytime you're increasing pressure, the comment was about a system tripping a high limit repeatedly for years. Anytime you're increasing pressure in the system, you have a potential for higher discharge temperatures or lower discharge temperatures when you're conditioning the air. Most zone panels, the IO zone panels, the Honeywell zone panels, are going to be monitoring that discharge air temperature for that, and can give you some additional controls so you don't put too much strain on the equipment itself. But at the same time, you do need to know how the system's going to react to the pressure increase, and whether that's by adjusting the settings, adjusting the setup on a variable speed blower, or installing a bypass damper. bypassing a bypass damper or installing a zone system with some kind of static pressure relief, like the IO ESP system. You have to deal with that pressure, at least know what it's going to do. Because if you don't, you could end up with, one, you're going to potentially end up with very noisy ductwork, which is a huge nuisance and is almost guaranteed to result in a callback. At the worst, you could damage or cause issues with the equipment. But static pressure is a big thing with zone panels. Yes.
Okay, Jose asked a quick question here. He said that he has a client that he's installing a system for, and they don't have a grill return. They use the ladder in the hallway because the grill return is in the first floor. He wants to know if he can install the thermostat close to the ladder in the second floor.
Install the thermostat close to the ladder. I'm not sure I understand the question. I mean, you can install a thermostat where you want to install a thermostat wherever it's going to be convenient for sensing temperature. Where the return is located is not necessarily that relevant.
I'll see if I can get some more information.
Yeah, sure. And of course, you're always, if you have very specific application questions with specific jobs, you're always welcome to call in. And myself or the other engineers here are always happy to help. All right, so moving on from there. So the components here are primarily the components you're going to need for a zoning system. You're going to need thermostats, you're going to need dampers, you're going to need a zone control panel, discharge air sensor, some method of static pressure control, and I don't show it on here, but we always recommend installing a separate transformer for the zone system. I'll talk about that here in a second a little bit more, but that helps with troubleshooting, helps alleviate a lot of issues that pop up from time to time. So talking about specific zone control panels, there's all different kinds available. Like I said before, you want to make sure you select a zone panel that's going to be compatible with your equipment. There's 2-zone, 3-zone, 4-zone, 6-zone. Some of the IO boards can go up to 12 zones if you got a really big house or you just want a ridiculous degree of control over individual rooms in your house. Excuse me. You want to make sure you get a system that's compatible with what your system runs. So it's a heat cooler or a heat pump. If you have dual fuel, a dual fuel system, you want to make sure you have a panel that can control that. Most panels have auto changeover now, so they can deal with receiving conflicting calls from thermostats. If one thermostat's calling for heat, another calls for cool. Most boards are going to be able to handle that these days. Yes, ma'am.
Okay, quick question from Frank. He would like to know how you keep the ECM blower and bypass damper from fighting.
That's a great question. That actually kind of goes back to what we were talking about a second ago. It's a question that comes up from time to time. So first of all, if your ECM blower is capable of dealing with the increase of static pressure on its own, you may not even need a bypass. Depending on how a system's set up, if your zones are fairly equal, and depending on your duct size, and there's a lot of variables here, but if your zones are fairly equal, the amount of static pressure you need to relieve isn't always that much. Sometimes it can be, sometimes it's not. Like I said, every situation is different. So first thing is, if you have an ECM blower, if it can deal with the increase in static pressure on its own, then you may not even need a bypass damper. That's the first thing I would look at. Beyond that, I would try to set it up so that the bypass damper wouldn't react until the ECM blower has basically done all it can do, right? So when the ECM blower gets to about as far as it can go, only then would the bypass damper start to open up. So that would be a little bit different setup than we normally would do on a bypass damper, because normally we want the bypass damper to just start opening as soon as the zones start closing. So that'd be a little bit more of a nuanced setup. But generally we want the ECM blower to do its thing, and then after that, if there's additional static pressure to be relieved, we would set the bypass damper to begin bleeding at that point. So thermostats. So we had a question earlier about some thermostats. So most zone panels are going to be able to handle most thermostats. There are a few incompatibilities out there, but they're relatively few and far between. There's all kinds of options. Obviously, a lot of the focus and a lot of the excitement these days is around the Wi-Fi thermostats and your smart thermostats. For the most part, these are going to work just fine on most of your zone panels. In most cases, you will need a common wire. I know the IO zone panels do not play very nicely with power stealing thermostats. So any thermostats that are going to give you a little bit of a non-standard signal back, whether it's a power stealing, you might only get 18 volts back or something like that. Not every zone panel is going to read that properly. So we recommend staying away from that. But for the most part, most thermostats are going to work. So some of the questions you need to talk to your customer about and the things you need to look at when you're laying out the system. One, do you need hardwired thermostats? Do you need wireless thermostats? Do you need Wi-Fi thermostats? So depending on where you're wanting to place the thermostats in the house, some may be more accessible than others. If it's not going to be convenient or even possible to get wire pulled from one area where you want a thermostat at to where the zone panel is going to be, then you may need to have a wireless thermostat. And most wireless thermostats will work just fine with most zone panels. But if you're going to be mixing and matching hardwired and wireless, if you need your thermostats to match each other, that's going to limit the options quite a bit, because there's a lot of wireless thermostats are going to be different style-wise and setup-wise and have slightly different options. So a lot of homeowners may not want different types of thermostats or different interfaces on different thermostats in the system. So that's something to talk about. Wi-Fi thermostats, again, if you put all Wi-Fi thermostats on a zone system, it's going to give the homeowner a huge degree of control and visibility over their home. Most of the Wi-Fi thermostat manufacturers are going to support multiple devices on their app, so you'll be able to pull their app up on the phone and see all three zones on there, see how the temperatures are doing, control and change set points and everything like that. Of course, brand preference is a factor. And again, thermostats must match equipment configuration. In most cases, both the thermostat and the zone panel have to match the equipment you're controlling. So if you have a heat pump equipment, you're going to need heat pump thermostats and a heat pump zone panel. But any of the thermostats you see there on the screen will work for you. And many, many others. Yes, Jillian.
Okay, before you get into the next slide, I thought it would be a great time to ask a couple of questions here.
Go ahead.
Our friend Constantino has a question. He would like to know, if your zone system fails, how will the dampers fail? Will they fail open or closed?
Depends. Depends on what kind of dampers you got. So on a two-wire system, so there's a couple aspects here. So on a lot of zone systems, they're going to default to an open position. So for example, on the IO panels, when there are no calls at all dampers will power open. If you're using a two-wire dampers are going to typically be power closed, spring open. So if there's a failure there, they should return to the spring open state. So you're going to have open airflow. If you have three-wire dampers, for the most part, those are going to just stay wherever they were when the system went down. However, in the case of any of the systems where you've got these dampers, we hit these Belimo dampers have a clutch release on them. So if they need to be manually opened or closed, you just press that and you can manually open and close the damper as needed, or manually open it so you can get airflow again. But yeah, if there's a failure state, spring return dampers, power close, spring open is typical for zone systems. 3-wire dampers are typically just going to stay wherever they were when they failed. And you have another question?
Okay. William asked if you can use a duct weight on the zone system.
A what?
A duct weight?
A duct weight? Mm-hmm. I'm guessing he's talking about a barometric bypass damper with the weighted arm. That's one option for pressure control. And that'll have the arm on the outside of the damper that's going to be weighted that you'll adjust that will respond to the static pressure. There's different kinds of bypass arrangements. You could have a barometric bypass like that with the weighted arm. There are electronic bypass dampers that use an electronic static pressure controller to bleed air, or there are integrated bleed-through systems where it's going to relieve static pressure into the non-calling zones, like the ESP system. But yes, that's an option for pressure control. Is that it for now? All right. Moving on, a little bit more for dampers. So some considerations for dampers. One, 2-wire or 3-wire. Sometimes that just comes down to personal preference. Sometimes that comes down to compatibility with the zone panel. 2-wire dampers, like I said, are typically power closed, spring open, whereas 3-wire dampers are power open, power closed. One big thing there, the third bullet point is a big one: accessibility and serviceability. Please, 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 for the love of God, do not install zone dampers in a place where no one could ever get to them again, if at all possible, because it could be you. Obviously, you can't control what the homeowner is going to do after you leave, so if you install some dampers in a basement and they decide to finish their basement and hide all of their dampers behind drywall, there's nothing you can do about that. But I would highly always encourage you to put them in locations where they are as accessible and as serviceable as possible. The dampers we carry all have a 10-year warranty, which is a pretty good long time, but it is, as you may have noticed, not forever. Eventually, those dampers are going to need to be checked out, serviced, or replaced. So don't hide them in places where they can't be gotten to. One other major factor for dampers is to pay attention to the VA rating on the dampers. Different actuators are going to pull different amperages. So pay attention to how much current load you're putting on your system or on your transformer with those dampers. Typically, people are going to install a 40 VA transformer with a zone system. And in a lot of cases, that'll be fine. But if you look at, so the 2-wire dampers from IO, these here, these are rated at 10 VA. So these pull 10 VA each. All right. So if we were looking at this zone system over here, where we have 5 dampers, if we put 5 10 VA dampers on a 40 VA transformer, we could end up with some blown transformers. So you want to pay attention to how much VA you're putting on your system. Other dampers, like these with the Belimo actuators, the 3-wire actuators only pull 2.5 VA. So you can put a lot more of these on a 40 VA transformer before you run into trouble. These are a lot more efficient, really efficient actuators. So that's something to consider. So keep an eye on how many dampers you're putting on the system and how much VA they each draw to make sure you're not going to overload your transformer. If you need to, you could either shift to a lower VA rated damper or increase the size of your transformer. Jillian.
Okay, we have a question from Frank. He would like to know if you know of any fire rated dampers that can also work in zoning.
Not that I know of. Typically, fire dampers are a kind of a specialized area. We don't really get involved in fire dampers, and you would not probably want to mix and match fire dampers and zone dampers. So as far as I know, I don't know of any that are recommended for use like that. I'd be surprised if there are, just because of the way fire dampers operate, but it's possible, but I don't know of any. Typically, those are going to be very separate functions. Next step along here is pressure control. So like I said, you must account for the increase in pressure control. There's a lot of ways to do it. You could go anywhere from, there's some methods we don't recommend, like dump zones, things like that. We don't typically recommend dump zones just because they tend to be pretty inefficient. Basically, you're going to select a space in the house or in the building that you're just going to say, yeah, I'm just not going to control the temperature at all in there. Some people that's okay, but we generally don't recommend it. The old preferred way is with bypass dampers, bypass and bypass damper. So you're going to route excess air from the supply directly back into the return through the use of a static pressure controlled bypass damper. And of course, the zone panel, you're going to want it monitoring your discharge air temperature as you do that, because your discharge temperature could change pretty rapidly as you do that. And then these days, there's a lot more options. A lot of them prompted by some legislation in California lately where bypass dampers out there are now illegal. So there's a lot of other options out there. Honeywell has some fixed bleed-through zone dampers. There are things like the barometric zone damper or the IO's electronic static pressure zone control, which are going to relieve excess air pressure into non-calling zones instead of bypassing it. So there's a lot of options there. Some more preferred than others. But you have to at least consider the pressure control. We know there's a lot of people out there that install zoning and don't put any kind of static pressure control at all in. We generally don't recommend that. Sometimes you can get away with it. Sometimes you're going to have problems. Even if it doesn't cause, even if your increased static pressure doesn't cause any actual harm with the system, if it causes enough noise coming out of the registers, that's going to be a callback, almost guaranteed. And lastly, just know what accessories to get with your zone systems, whether they're discharge air sensors, return air sensors, outdoor temperature sensors if you've got a heat pump panel that's controlling a dual fuel system, and a transformer that is properly sized. And again, we typically recommend using a separate transformer from the equipment transformer, mainly because on most zone panels, you're going to have complete electrical isolation between your inputs and your outputs to your equipment. And we want to be sure of how much load we're putting on that transformer. With your equipment transformer, you can't really be sure all the time how much load's already on it. So by putting in a separate transformer, 40 VA, I know I have 40 VA available. Here's my dampers and my thermostats. I'm good to go. And then you don't have to worry about it again. So that's the last thing I have. That went quicker than I expected. So, we didn't have any questions? Yes?
Address the bypass. When to use it, when not to use it.
The question was when to use a bypass and when not to use a bypass. So typically what we recommend is we find that duct systems start to get noisy at about 0.4 inches water column. So if you can close down your system with only your smallest zone calling and you're not exceeding that, you don't need a bypass damper. And usually you can tell by the noise. If you close down everything but your smallest zone and run the fan at full speed and there's no whistling or anything, you're probably fine. and most of our static pressure controllers, whether it's a bypass or built into a panel, that's usually the control point we're going for, about 0.35 inches, 0.4 inches water column. We generally don't want to exceed that because that's where you're going to start to get noisy, and that's where you're going to start to get nuisance calls. Any other questions?
I have a couple of others that came in.
Shoot.
Okay, do you want to go? Okay, so Frank asked if your transformer is too small for all zones, can you put another one in parallel to get more amps?
I would not do that. So I wouldn't just parallel two transformers together. I would increase the size of your transformer first of all. So I'd replace it with a larger rated one. In some cases, so you could get by with having two transformers. You got to be careful how you do it. On some of the older systems, a lot of times what we would do is on the outputs, on the damper outputs, instead of running that straight to the damper, we would just have that trigger a relay, and then we would feed power directly to the dampers from a larger transformer so that we weren't running all that power through the zone panel. So that's an option. You can use isolation relays to power the dampers directly. But I would recommend increasing your size rating of your transformer before I'd parallel two transformers together.
We have one more question here from Constantino.
Okay.
He would like to know, if you use a hydronic zone control, can you set it so the actuator will close or open the valves on the fan coil?
Hydronic zone control, so can you set it to open or close the valves on the fan coil? I'm going to say yes, probably. We really don't get involved in hydronic zoning too much here, so that'd be dependent on the specific zone control that you were using. But I would assume that most of those can do that. But unfortunately, I don't have a better answer for you than that. We good? All right. Any other questions? All right.
Good?
Yeah,
Is that all you have for us tonight?
that's all I got.
That was great.
Thank
A
you.
lot of great information from Elijah tonight on the basics of zoning, a great intro. If anyone has any other questions, please go to jacksonsystems.com. Find our main number, call in. You can email us questions, whatever it may be. We're happy to help you through this. Thank you so much for joining us. We look forward to seeing you at our next training. I believe is next week. You can always find that schedule, again, jacksonsystems.com.
I got one more thing. One more thing before we
He's
cut
not
out.
done.
I will say we do, like I said before, we do have a more technical zoning training we're doing, I believe May 5th, where we'll talk about installation, troubleshooting on zone systems, and some of the things you can do if you get called out to a service call, or if you're installing a system and it's not working right. So we can usually fix that for you. Just thought I'd throw that out there.
Awesome. Thanks a lot, guys.
Thanks for watching the video. Be sure to smack that like button below. And if you want notifications on brand new videos that are coming out tailored just for you, be sure to subscribe right here to the Jackson Systems YouTube channel. Now, if there's some videos you missed, you can always check it out right here. Go ahead and click subscribe. Other videos, like, do it.